Hello, in this video I'll tell about cellular automata and some other things. In this video I'll show 6 game of life like cellular automatons. You will know what these numbers mean and show some non-automaton cellular programs. So let's go. This is my cellular field. I created it using Rust WebAssembly, HTML and JS. Take a look at this, it's my creation, random tree. Such things we can do here. This is how it works. Each cell has a few fields, direction of growth and number of tiles to grow. When a tile has spent their steps number, it will send from 0 to 3 sprouts in random directions. Okay, here is something more interesting. I already did something like this in my older video Cellular House. When atoms are far from each other, they will attract each other. When close, they will repel. Here are some bigger atoms. And here are some smaller. Don't be fooled, their force fades with time and their structure stabilizes. But both of them aren't cellular automatons, and here is why. Cellular automatons process states of cells in some range or neighborhood. For example, such two ones: von Neumann neighborhood and Moore neighborhood. Here we will use the Moore neighborhood. Anyway, simply applying cellular grid onto any graphics object isn't a cellular automata. Okay, so let me show you a real cellular automata. Maybe almost everybody of you heard about such automaton as Conway's Game of Life. Let me show it in action. How it works? It's very simple. When a green cell has lesser of 2 or greater than 3 green neighbors, that cell dies. When a black cell has exactly 3 green neighbors, it becomes alive. Okay, let me show you a few more cellular automatons. Here is amoeba. It acts very likely to a real amoeba. Also, you can notice such wiggly structures. Actually, before making this video, I simply launched the Powder Toy and checked their implemented versions of Game of Life. I have borrowed their names, and here is Day and Night Cellular Automaton. Really, both Amoeba and Day and Night are very similar to Conway's Game of Life, and you will figure it out soon. Its main property and why it is named so is because it can be inverted and it will do the same things. You can see how this automaton is creating like rotating and pulsating structures. They resemble sun and moon to me. Let's look at this cellular automaton. Its name is Wallet Cities, and here is why. Set like to the video if your city is exactly the same. Let's make it bigger. Okay, so why these three automatons are very similar to Conway's Game of Life? Take a look at this formula. How do you think what is meaning of their elements? Pause the video and write your opinion in the comments below. And I'll give you some clues. This is formula for Conway's Game of Life. And there are formulas for our last three automatons. So B states about how much neighbors for a dead cell are needed to born a new cell, while S states how much neighbors for living cell are needed to survive. So you know now, if you didn't know before. Also you can find formulas looking like this with additional number. They are referred to cellular automata with more than 2 states. You can find more by googling Brian's brain cellular automaton. Now let's take a look at a few more automatons. Here is Stains, simply watch what is going on. Very stainy. This automaton is named Long Life. I don't know why. Let's make a bigger version. I didn't program a right tool to create a bigger brush, so I need to draw it manually. It is how it is working. And finally this. Its name is Assimilation. Here how it goes. Let's make it bigger. Let them take over the world. And also I'll eliminate these animated particles. So this is the end. Don't forget to subscribe and set like if you liked the video. Hope it was interesting and informative. I'm going to create more content.